Hello, Internet. My name is Amy Dickens, and today I'm going to walk you through an introduction to Sonic Pi and making music with code. Now, before we get started, I'll tell you a little bit about myself. My name is Amy, as I've already said. My handle, you can see down there, is Red Rocks Projects. You can find me on the internet most places using that. And I'm from London, and that's where I'm presenting from today. And yeah, how did I get into making music using code? Well, I actually did a degree in audio engineering, which I started 10 years ago now. I did finish it too, but when I started it was 2010. And I have since then been an engineer in studios, a live sound engineer, and I have worked kind of in all aspects of mixing and mastering as well. One of the things I then moved on to was to do a PhD in computer science, which I'm now finishing up. And that kind of got me into going to hackathons and learning and sharing the skills I had as an audio engineer on how to build cool music hacks. And for the last 2 years, I've been working as a developer advocate and giving talks on tech and helping people learn new skills, and run meetups and do all sorts of fun things about teaching each other new skills with code. And this is one of the things I really like doing. I actually discovered Sonic Pi, I want to say 2 or 3 years ago now, and I really love giving this workshop. I've done it a couple of meetups, so hopefully you'll enjoy listening to this today, and it'll get you started with Sonic Pi. Don't worry if you have no experience writing code or no experience making music. Neither are required for this workshop. We're just gonna get you from zero to starting with this, and then hopefully by the end of this you'll be making some noise and messing around. So let's get started. Now, before we do anything, do check your audio settings. The one thing that I would recommend is having a pair of these handy, so that when you start messing around, you plug in your headphones and do everything through that. Just because anybody you're co-working with right now might like you for that, but also because if you do accidentally trigger a very loud sound in your ears, you can kind of throw them off and the sound can continue playing as opposed to trying to fix it whilst it's happening. It's kind of high pressure. Don't worry, everybody does it when they start messing around with any kind of audio programming. You often will make a loud noise by accident, and I just want you to make sure that you do everything you can to look after your hearing and your ears because they're really, really important. Okay, what will we cover today? Well, today we're going to look at music programming environments and kind of the creativity problem that exists there in learning them and just the accessibility of getting to use them as well. Then I'm going to introduce you to Sonic Pi and what that exactly is, and then we're going to walk through how it actually works. So hopefully you'll gain some skills to start using that today, and I'm going to send you away with the task of making some noise yourself. So by the end of today, you'll have a cheat sheet to start making some noise with Sonic Pi, and hopefully you'll have endless hours of fun messing around in it, as I know I have since I started. So let's talk about music programming environments and the creativity problem. Now, if you aren't a musician yourself and you don't necessarily write code, you don't need to worry. We're going to start from the point of imagine that we have, say, a bunch of musicians, okay? This is kind of how we think about making music, because we think about somebody practicing a craft, picking up an instrument, learning it, and spending time then learning things that they could do with that, or just picking one up and noodling around and messing around. And we have this kind of idea of how to start making noise with any of these instruments. Fair enough, we might not be able to start right away being musical, but if you saw a piano in a train station, for example, you know to walk up to it and press a key and that will make some kind of noise. And the same with a drum. Like, you see a drum, you know that you need some kind of drumstick or beater, and you'll walk up to it and strike it and it will make a noise. Again, like, you need to then spend time mastering it, but the actual discoverability of how to start is quite accessible. You have these ideas of what these instruments can do over time. You've seen them in music videos, you've seen people playing them on stages. You have an idea. With computers, it's not so straightforward. And understanding how you could get started or get started getting the computer to make noises for you, that's a learning curve in itself. Now, if you've tried to look into this before and thought, oh, I'll have a quick search on the internet for music programming environments, you might have come across these two things, which are MaxMSP and Pure Data. Now, these two are similar in that they're both visual programming environments. So they come with their own IDE, which is an integrated development environment, and you work within that and you create objects that can do different things, and then you connect those objects with something called, they call them patch cords, inside, which is kind of like cabling, is kind of like routing signals from one object to another and controlling them. And they require a lot of learning. You start at the very basic elements, creating something, and then you have to walk through before you really start getting into the being able to create complex musical structures with them. MaxMSP you can purchase at cycling74.com and actually has some really cool links in with Ableton if you know that as a digital audio workstation software. And Pure Data is the open source free version that you can get. But I'm just going to walk you through their interfaces just to kind of give you a quick idea. Now, this isn't necessarily a fair example of both of them, but when you start getting to complex stage stuff and power users of the two programs, what you might find is you'll stumble across patches that look like this. So here is one that I've taken from the Cycling 74 forums. This is MaxMSP, and as you can see, there's lots of these boxes. These are some of the objects. Some are objects, some are messages, some are buttons, some are toggles, some of them are matrices as well. And you can see there's all these different cables flying around, connecting things together. Some of them are coloured, some of them are dotted, and they each mean different things. So you can understand that to get to this stage of plugging things together and all of these objects and what this might be doing, this can be very daunting. And as a new user to these things, you might get a bit confused / intimidated by looking at an interface like this and trying to figure it out. And it can be quite unnatural to get used to as well. Like the idea of connecting something up, starting with an object and then connecting it to another and understanding which is the out signal, which is the hot signal, and how to affect each of the objects. Each object takes a time in itself to learn. So you really have to go from baby steps with these things to be able to then start producing music. So you're not going to be able to just walk up to it like you could a piano and just start making music right away. Similarly, Pure Data, the open source version here, again, I've taken this from somebody's blog about some of their Pure Data projects. It can just look as intimidating, and it's a bit much if you're trying to learn, and especially if you haven't come from somewhere that you have a background in audio. I say that because as an audio engineer, this idea of connecting signal and flow using patch cords to me is something that I learned way back when in studios. So I don't know if you've seen one of these before. This is a patch bay, and this is how you do signal routing within a studio environment. So not every studio will have one. It depends on the size of the studio and how much outboard gear they have and what kind of desk they're using, whether they're a digital only studio or an analog studio. But this is how we would do it back in an analog studio. We would take a signal out of the channel path or somewhere before the channel path and take it to a piece of outboard and then plug it back in. So you can see all these cables that are connecting things. We call them patch cables. And that's how you would be able to, say, put a compressor or a reverb into the line of a particular sound signal that you wanted to affect. So it's kind of a concept that comes from there, and this is where those visual interfaces have been designed from. And so it's kind of assuming some knowledge on the person who's starting to learn its point, that you would understand that signal flows this way, or that things come into the top and, well, come in and out in different ways from different objects, and that's what you want to have as a concept in your brain before you begin. So it can take a lot to learn them. And yeah, it's just, this is kind of how I see that they kind of crossed over into a visual graphical interface. But I want to talk a little bit about something different today, and that's actually using code to write music. So what is Sonic Pi, and how does it solve this issue of, oh, that's a bit much to get started? Well, Sonic Pi is an alternative to these visual programming interfaces, and you can create sound synthesis and more inside of it. And it's really accessible, actually, in terms of the language it uses, the objects that have been created for it, and how it's been built. So it's available on a Raspberry Pi. It actually comes pre-installed on Raspberry Pis if you own one. And it's based on a programming language called Ruby. And if you've ever heard of Ruby, you might have come across it in web development for Ruby on Rails, or some back-end development stuff. It's a quite friendly language, very beginner-friendly language, and the version that Sonic Pi uses is made even more so because there's a lot of instructions that are pre-created for you inside of the environment. So if you want to get messing around with it today, you can go to sonic-pi.net and download it. It's available on Mac and Windows and Linux, and as I said, you can get it on your Raspberry Pi. So if it's not already pre-installed on one that you own, you can get that down onto it as well. And yeah, it's free, it's open source, it's cross-platform, it's really fun as well, and it's based on one single rule. And that single rule is, can a 10-year-old use it and understand it? So this is a really nice ethos to have in a programming language specifically, and a development environment, because it's not trying to impose any assumptions or knowledge on the people using it. It's saying, if we wrote this in set of instructions, or we built this object to do this particular thing, would a 10-year-old be able to do that and conceptualize that and understand it? And if they can, then it goes into the program, and if they can't, then they have to work on it until they can put it into the program. And I really like that about it, and I can honestly say, like, it does break down that barrier of just being able to go straight in and start messing around and making noise. Okay, so let's get started. And you might be saying, hang on a second, don't I need to know about code or music theory in some way to be able to do this? Truth? No. It might help when you start trying to make something a bit more musical if you have a bit of an idea of music theory, but realistically, this is a program where you can't really make any mistakes. You might not make great music right away, you might make more noise than music, but you can just get started and mess around and start doing lots of fun things today. It's really creative, and I really like that about it. So let me show you what Sonic Pi looks like. Okay, here we go. I'm just going to get rid of this for you. So here we have the coding environment. What you'll find is, on this left-hand side, we have the area where we write our script. So I type in here. As you can see, it's already started highlighting things that are actual instructions. So I type my code into that part. Then we have this log, which greets you with a message at the beginning about development. It's telling you my version needs updating. I'll get right on that. But then also where you can find more information. And along the bottom, you'll notice that we have this number of buffers. Now that's allowing us to have multiple scripts. A buffer is something that we think about in audio as like a storage space for samples and things like that. And you've probably come across it if you've ever tried to watch something online back in well, way back when you just used to get the spinny wheel and it used to say buffering all the time. But a buffer is like a storage space. And each of these can contain a new script, which means that you can have up to 10, so 0 to 9, different scripts running at any one time, and you can move between them. And it's really great because this actually allows you to do a lot of live coding, fun stuff that Sonic Pi was designed to be able to build music like with code live as well. So other things that you might want to do, as I said, check your sound settings. So up in this right hand corner we have preferences. I've set the master volume about halfway here, just to make sure it's not too loud on the recording. You might want to just check what it sounds like. Just make sure that you maybe start with a little bit lower and then turn it up. Don't start with it all the way up, because that's when you might get one of those horrible loud noises in your ears. But this is where you would come to set all of the different audio settings. If you're looking for something, will be in the preferences here. We can make that disappear. Then we also have things along the top in terms of like increasing our font size. We can also hit here to see all the info about Sonic Pi if you wanted to know more about it, or find information on the community to get support, or if you want to learn about the team that built it. It actually was built out of the University of Cambridge Computer Labs, so there's all this nice information in there as well. And the other really great thing is all your documentation can be accessed via pressing this help button in the top left, and you have all of the tutorials, including like a welcome message to Sonic Pi, and examples that you can copy the scripts and put them into your buffers and see what they do. You also have every kind of possible synth sound, every effect that is part of the library, all of the samples that come with Sonic Pi, and also different elements of the language. So if you wanted to understand about what each part of the language did, you could look at this and it would tell you exactly what that is. So if you wanted to understand, for example, maybe let's just have a look at one of the examples we're going to see in a little bit. Where am I? Yeah, play. So play, note, symbol or number. It'll tell you what it plays with the current synth that you've got selected. So gives you all of this information about each of the bits of the language as well, which is great. So let's head back. I'm just going to get rid of that help for now. Let's head back to the presentation. The first thing I'm going to show you is these two parts of the language, these two commands that you can start with, which is play and sleep. Now, the reason I'm starting with these first is because you can start building a very simple melody quite quickly using both of these. So we have play and then a note name. I've put a colon here because if you're going to use a note name like C, D, E, F, G, the notes within a musical scale, don't worry if you don't know them, you don't need to. You need to put the colon beforehand. You can also give this command a MIDI note value and frequency too. You can also, on the one below, sleep is like a rest, and the rest value, you just give it a number for how long you want it to rest for. But I'll show you those both now. So, as I said, I type into this part. Let's have a look at those in action. I'm going to play the note C, and we just then hit this run button at the top to hear that. Okay, now we just hear this beep, and I run it again if I want to hear it again. At the moment it's not repeating itself or doing anything like particularly interesting. What I'm going to do is tell the instructions to sleep for 1 now, and then play I'm going to say play a D, and then again sleep for 1, and then play an E. So now you should hear. Here we go. Okay, so now we have those notes one after the other. Now, the reason I include the sleep is because without that, if I were to just have these 3 instructions one after the other, even though they're on separate lines, they'll all play at the same time. So the sleep actually gives a secondary instruction that tells the computer to wait before playing the next note. And the duration that I give it is 1, which is the same length as the note it's being played. So one will play one after the other. If I increase that gap, you'll note that you'll see what happens here is that you have a note, then a rest, then a note, then a rest, then a note. So that's how you create the kind of counting that you would in music. And if you've ever even started learning a musical instrument in the past, you'll know how important counting can be in the beginning, and how many beats in a bar and those kind of things. So that's what you start learning with when you're learning the basics of music. Now, the next thing that I wanted to show you was this instruction called do. So do actually lets us now do a little bit more with this in terms of creating a set of instructions and being able to repeat those. So when I'm writing out this script, if I then wanted to write a whole melody, it might take me a lot of lines of this play, sleep, and it also might get a little bit more complex, and there might be sections that repeat themselves. So if I have a section that repeats itself, what I really want to do is come back to that so it repeats again. I'm just going to find the example. Okay, so I created an example here where we use this do. Do allows us to create a loop, and I say 2 times I want you to do this, and then there's the beginnings of what is the nursery rhyme for Erojeka, and then end. So if I hit play on this, so because there's that repetitive part of the beginning of the song, I don't have to type this out twice to be able to write the melody of the song. I can actually just tell the script to run the same thing twice. And that's really helpful if you want to start getting, getting a lot of melodies playing, and you can start like repeating sections quite easily by just telling it, oh, well, just do that twice instead of having to type it all out again. Okay, so another great example that we have, or another instruction that we can use within Sonic Pi is sample. And sample lets us take a sample of audio from either our computer or the library that comes with Sonic Pi and use that within our code somehow. So sampling, you might have heard of as a term that gets used in music, is when we take a piece of audio from elsewhere and use it within our own song. So you might have heard popular songs on the radio sampling songs from way back when, or like old rhythm and blues songs. And this is something that happens quite a lot in the music that's in the charts. So to do this, I've just set up an example that uses one of the loops that comes with Sonic Pi. And this is a quite famous loop, actually. It's called the Almond Break. And if you've done things with audio engineering or mixing or editing before, you might have come across this. It'll be quite familiar to you because it's one of the most used drum loops of all time. But what I've set up here is using this sample, and I've picked out the sample from the library that comes with Sonic Pi, which is this Almond Break loop. How many beats is in the sample, and then created another of these do loops. So like, how many times do I want you to play it over? I want you to play it 4 times. This is the sample I've chosen, and I want you to sleep for 4, which is the number of beats within the sample. Again, we need this sleep command because if we didn't have that in there, it would just play on top of itself. And that's, it's our way of making noise. It's definitely more noise, and it's a bit of a cacophony of sound. But this just means that it will wait before triggering the sample again on top of itself. So let's have a listen at what that sounds like. There we you go, recognize it? Okay, so that's how we can sample stuff, and you can start to see now how we could take audio samples and other loops and start really building some complex music using this as a way to do so. So sample. What other things can we do? Well, you can do so much stuff actually, and once you get in there, I do recommend going through the tutorials and looking at the examples and just having a bit of fun mess around with it. You can add effects, you can do sequencing and generative audio as well, which is really exciting. You can even do things with 8-bit sound because of all the synthesis that's available in Sonic Pi. You can actually pick some of the classic 8-bit sounds, so make Game Boy soundtracks or the old school soundtracks that you might have heard on an old games console and mess around with those too. So I'll just show you some other examples I had lined up. So that's my do loop. One of the things that I found quite useful is learning how to actually define my own kind of functions within the Sonic Pi code. So I want to be able to set these up later and I can call them at any point within my coding session or live coding. So I'm just going to get rid of this and show you that because I've got these definitions up here, even though I have some do loops, they're not going to play if I hit run. Because what I've got here before is this word define, and that's telling the system that I am just telling you what those things are, and when I call them, I want you to play them. Very much like defining a function inside of many programming languages, it won't actually occur until you call upon that function to execute. So I'm now going to do that by just putting in 2 notes down here, which you'll see is the name of the first one that I've defined, the first definition I made here. And now when I run this, what it does is just runs this first do loop for you. And if I decide that I want to run it twice, I can do, there's different ways to do this, but I can just write 2 notes out again and then. And if I decide that then I want my 3 notes section to play, I can hit the 3 notes and type that name in. So it becomes this kind of pattern that I can create. And this is great because if you are doing something like deciding that you're going to live code a song, what you can actually do is create all of these melodies that you want to have ahead of time accessible and just code them in when you want to call upon them for your section of your song. Similarly, I've done the same thing here, but building upon this, I've called them in a slightly different order at the bottom, as you can see here. First 2 notes, then 3 notes, then 2 notes. But I've actually used this command called use synth, and that allows me to change the sound. So until now, when I've been writing my pieces of code, all you've heard is this kind of the standard synth sound that comes. But actually, when I type use synth, let's get rid of that particular thing right now. If I type use synth, what you'll see is it gives me an optional list of kind of all of these. So maybe let's hear let's choose that Pretty Bell again and see what that sounds like when we play this 2 notes, 3 notes thing. So again, this is just a very simple melody. It's not particularly musical. It's just something that I wrote out as an example. And we can change the synth sound and we can change the order, and you can start to see how you could build up songs inside of Sonic Pi. That's that almond break. Okay, now getting more into the examples that come with Sonic Pi. So again, remind you that you can find these under help and you can look at examples. And essentially you can take any of these from here and you can copy it from here and put it into your buffer to see what it sounds like. So on this example, I've actually just wanted to show some of the generative audio stuff that you could do with Sonic Pi, which is randomization of sounds and using noise and filters and lots of other things that you can actually do to get a bit more complex. And this one is coded by Sam Aaron, who created the Sonic Pi language and code environment. So And this one sounds like an ocean, which uses lots of different types of noise and then lots of different filters to randomly generate different sounds that sound like an ocean. So here you go, let's hear it. There you go. Now, one of the things that's introduced in this example is a live loop. Now, that means, unlike our previous do loops, which just play the amount of times I tell it to, when you have a live loop running, it just continuously plays until you hit the stop function. So, and you'll see that it was queuing up here on the right-hand side as well, just so that it was going to play again and again and again and again. So that helps you to understand, like, how to see what's about to happen, and then the log is showing you what's happening as the program runs. So this is kind of how you might get into doing a lot more complex things, and this one's quite fun for the different kind of noise filters and sounds that you can create. But you can also do things like recreate existing songs. So this is an example, again coded by Sam Aaron, that I really like. Is just see if you can guess the song. Again, this is a live loop, so I have had to hit stop here to get that to stop. But it does just keep running through the introduction of that song, just constantly building, and it never actually gets into the full chorus or anything. I like to play this as an example as background noise before my workshops, or during my workshops when people are working, and you wait for somebody to be like, oh, how come it doesn't go into the full song, and you're like, yeah, it's just the intro. But it's really quite fun to see how few lines of code here. So what if you've got 9 to 39, so about 30 lines of code here, or just over, to write out this whole piece of music that just repeats and repeats and repeats. And that's really cool. What else have we got? Okay, so I mentioned beats before when we were talking about the duration of the note versus the duration of sleep. So the play and sleep function rely on something called a beat. And that can be controlled by using a BPM modifier. So BPM is beats per minute. And if you've done anything with music before, you may have heard this, you may have seen this on particularly dance tracks have a high BPM. Or if you've done any remixing or DJing, you might have heard of this. But we rely on beats per minute to kind of set the tempo of a song, or set the time of a song, or how fast it plays. So here we have Bach's Minuet in G. I'm going to set the tempo around 80 because that should sound kind of natural. So using up here at the top, you'll see there's this piece of code saying use BPM. And I've set it at 80, which stands for 80 beats per minute. So let's hear that. Okay, so that kind of sounds about right. But if we wanted to now, like I could set this at 120, which is going to be much, much faster and getting more into like the dance realm of BPMs. Again, do not worry if you don't know like what to expect out of a certain BPM. The nice thing about Sonic Pi is you can just start messing around and hear things by messing around with the values, and then see what you think works best. And the way that this does that is it affects everything in the code from the first note onwards, and it sets that as the BPM for, so every rest value and sleep value, every play value and sleep value will be the same. They're still relative to one another, but they just both speed up. So here in 120, you'll hear that it sounds a little bit more fast, and faster than maybe intended. Okay, so that's how we can start messing around with the BPM of a song and affecting the code. So you're never kind of set at this one time signature that we heard before. You never set like at that pace. You can actually affect all of that as well. So you can start really messing around and making some fun music. Another thing that I get asked a lot when we start doing these workshops, and is usually like the next step forward, is okay, so I know how to change the synth sound, I know how to do a single note and play and sleep, I understand those, but what about duration of a note? What if I have a note that I think should be held for 2? Do I just type out that note twice, or how do I make that happen? Well, if we want a note to last longer, what we can do is just put a comma after the note name that we've given it, and then add this like an argument modifier that says duration, and then give it the time duration that we want it to play for. So in this example, I've just set the note A to play for 2 counts, sleep for 2, and then play C. So that should mean that I hear A and then C. And then you'll see what we can do with changing the sleep value and changing other things as well. So you can hear that one is sustained for a little bit longer than the other. If I change that sleep value to 1, what will happen is the C will play before the A is finished playing. And if I set that sleep value for 3, what will happen is the A will play, then there'll be a rest, and then the C will play. So again, it relies on this element of counting so that you can hear, but it's very helpful if you're trying to recreate melodies to know how to make the duration longer or shorter. Similarly, it can be a value of a point, so it can be a floating point value, so it can be a half note value, which if we do sleep 0.5, you'll just note that it's a little faster. So this is how we can try and create melodies. So if you've read music before or know like the values of a quarter note or a half note or all of these things, like a crotchet or a minute, like you might want to like emulate those inside of the code, and you can do that using these duration values. Okay, so I think that's all the examples it is that I had to walk through. So let's recap. Sonic Pi, yeah, it's a alternative to these visual programming environments that you might have seen for sound synthesis, and it's really accessible, so I do urge you to give it a go, because you can start literally creating sounds as soon as you open up the program. Just type in play and a note and you'll get something. The commands that we learnt today were play, sleep, do. Don't forget to end the do loop if you're creating something. And then define to set up multiple loops that we might want to call multiple times, and sample if we want to use any audio sample that we've either captured or have already on our computer. And right, now it's your turn, so I'm going to hand over to you. Here is, if you just don't know where to get started, here is a worksheet that I've created in my GitHub. It's on a GitHub gist. And you can either scan this QR code from the screen right now, or you can visit this link and it will take you right there. It gives you the MIDI note values and some other things for nursery rhymes, a set of nursery rhymes, because that's where I started when I started learning piano 25 years ago. So that's like, it's one of those things where you can start messing around, or just go and hang out in the tutorials or the example section of the documentation that comes within Sonic Pi, because there's so much fun to be had there, and just like messing around is part of discovering this piece of software. It's really, really, really fun. And yeah, I really love it because it breaks down this barrier in a different way to other programming languages I've learned for audio programming, and it just re-gives you that idea of walking up to something and just making noise like you could a piano or a drum or a guitar. And I really, really enjoy that it actually lowers the barrier to that much to be able to do this. So yeah, that is everything from me today. Thank you so much for listening or tuning into this and spending time with me to go through this. If you have any questions or you want to see the things that I put online about this, you can follow me at Red Rocks Projects. You'll find me on GitHub there or Twitter. You can also just email me here. I've popped my email in there for you. So if there's anything that you want to learn more about or ask any questions about, maybe there's a particular audio engineering thing that you want an answer to, let me know and I'll either record another video for you or I'll answer your question if you get in touch. And my direct messages on Twitter are open, so anybody can message me about this. I hope that it's given you a bit of insight on how to make music with code, and I hope that you've enjoyed the video. And I look forward to learning more about you soon and have lots of fun. If you do make something, please tweet me and share what you're making, because that would be really, really fun. Okay, bye!